Hello everyone, this is Bradley. Today this is a voiced recording to make a reactive particle emission animation. I don't think this is a very hard setup, although I can expect certain issues due to the limitation of the current system. But anyway, so let's start. So here we're in Blender. Actually, as always, I'm going to use the presets which you can download for free from the link in the description. But actually, the main purpose of today's recording is because I spent 3 days to learn coding and update the add-on. So different from the previous add-on, which we are doing the node linking. Where's the linking? Oh yes, we have the linking. Right now we are making everything into asset library. So that's why you start to have the panels back and everything is auto updated. I just want to test if this workflow is applicable or not. So anyway, let's start with the simplest setup. I'm just going to have a cube. So let me delete these group inputs. Let's just take a cube. Because we need enough amount of subdivision to evaluate, so let's make that maybe 55. Yeah, I think this is good enough. And then we can just plug in empty instead for the moment. So let's take a proximity fold. You actually realize that the panel, because we start to have this asset library section, so if you call and without calling it, the order of in the group nodes is different, which I think is kind of very annoying. Anyway, so we have this proximity fold, and I need a simulation zone to decide that I'm only going to emit particles in specific area. So let's point to distribute. I've discussed these kind of things in the past, that the good parts of this point distribute compared to the distribute points on face is that instead of using density, we can actually define the amounts. So making that 400, which is okay. And then we start to join geometry. We join new particles every frame. And for some reason, you can see actually this linkage goes above the original one. We need to manually link it. Okay. And then I need to limit DC emission only at the selection. We can use an empty to control DC emission. So we take this controller. And yes, I just move that away so you can see the particle only emitting from one side. Let's also take a join geometry. And then we get it. Then I need these particles to move. So let's store a named attributes of normal, which we will make that into a velocity. Actually, I do have a preset called set particle parameters. Let's just use it, which is basically doing the same, but we are adding variations in velocities and the direction. And then we need to set a position to these particles. Let's take these velocities into the offset. Then because the velocity is very high, then it will be emitted very fast. We can scale that down. Sometimes it's possible that the people recommend to scale in relative to delta time. This delta time is essentially kind of a function running in seconds. and it does not change with your, or it changes with your frame rate. So it's kind of a consistent value, but I don't like it. I just want to use more controllable numbers. So let's take a value position, which is 0.1 output in this case. And yes, this is working. This is too many particles. Let's just take it lower, 35. Okay. And then we also need to add some gravity. Gravity is a kind of a consistent value. So we store named attribute, which is G. Knowing that the value you're inputting in simulation zone, because the value will be looped back. So the value you input is actually a velocity. It's just like we're setting a normal value here and make that into the set position, but it's actually moving the particles frame by frame. So it's actually a velocity. If you do this kind of function outside the simulation zone, you will realize there's no animation. So this is the difference in parameters. Why is that important? This is because we're going to add these velocities together, make it into a simulation. Okay, so I have this G, and I'm going to add itself back. Name the attribute G. And I'm outputting this resultant G into the offsets using a add. Now this is going up directions. Okay, so now this is just falling to the ground. This value is still too high. Make that into 100 less, 1000 less. Okay, this is too less. Something like that. You can actually control the numbers. Yeah, I think this is fine. Okay. So if we play this animation, you can actually realize that when we get close, it emits particles. When we get out, it does not really emit anything. So this is the main core concept. Next, we are going to emit these particles as actual object. In Cycle, you can actually emit these particles in the render, but in eevee, you have to instance points. Otherwise, if we go to the render view, and we will not see them, even if we set a material. So let's put an emission shader. We have the material. Let's just call it particles. Okay. You will find there's no particles being rendered by eevee. So we have to take an instance on points, and I'm going to take a curve linear, and I'm going to instance that as a rod. So take a bevel curve, then it becomes a tube structure. If I fill the caps, and I make that into the round caps, so we have the round caps. You can increase the resolution so that it becomes rounder, and you can also set shade smooth. Then it will look kind of nice. And this is basically okay. The reason I often do this is because I do not want to mess up the motion blur. So sometimes the people can be tricked, but this is too large. So let's decrease the scale a little bit, maybe 1. And then we need to record the velocity. This is a simple math function in which you know that we record the position into the simulation, and this position get back to the start. And if you subtract the two positions, then you get a velocity. Okay. But one kind of issue is that we're already using the velocity attributes for this set position. So let's name that as other things. Let's velocity direction. Okay. It does not really matter what's the name. You can name that as X, Y, Z. But you need these attributes name being known somewhere. Align Euler to vector. And then we take these named attributes, velocity direction, and we take this rotation into rotation. Then you can see it looks like this. The direction is a little bit wrong, so we take a rotate Euler. Rotate rotation. Yes, and rotate maybe 90 degrees. So now it looks like this. Okay, so this is fine. Next, I want to scale these instances based on the lifetime that it should be small at first, and then it becomes large, and then it becomes small to disappear again. Okay, so I actually already recorded a burst time, which is t. So we need to store an age. So we store named attributes, which is a float or integer, does not matter. And we take this age and we name that as an a. Okay. So it's actually just store a scene time frame node at this store named attribute. Okay. So now we have this age. We can use that as a time for and the duration is 25. It means the age will last 25 frames. So if we directly use this scale, then what you can see is that this is how it looks. Okay, Falloff are all defined from between 0 to 1. So if you want to change that, you can remap 0 to 1. The reason for this design is because float curve or color rampers are all mapped to 0 to 1 range by default. And in this case, what I'm going to do is just to manipulate this 0 to 1 range and remap it to something else. Okay, and we get this effect. I think this scale is too large, so we take another value position so that we're scaling that by 10 times less. Okay, so we'll get something like this, and you can decrease the duration or increase the durations based on your needs. You can also change the lifetime based on the randomness. So this is 30, and we take it to this. Actually, I noticed some problems that this duration is an integer, but my value is a float. But anyway, I hope it can work somehow. We cannot really see how much it affects, but by changing the seed, then you can see the differences. It's not very obvious, but these tiny variations will make things a little bit more interesting in my opinion. We can also take another randomness to this scale as well. It's basically as you wish. So let's increase this timeline. And then if we control this empty, you can see we have no emission, start to emit based on the place we're hitting. Okay. So basically this is the idea. Since my goal is to make kind of a sparkle animation, let's take the age maybe low as 15. So it will last kind of a small amount of time. Let's also make that very large at the beginning, and it should decrease pretty fast. Something like that. Okay, I think this is fine. And It's also possible to add some noise texture into this velocity, but I don't think I'm going to do that here, because either way you won't be able to visualize these particles. What you can do is you increase the direction variances maybe to 35%, so it will be spread more out. Another important thing is that I'm going to change the seed of this distribution, because right now every frame is distributed at points the same way, but I'm going to use the same time frame. So you can see every time the particle is emitted in from a different place. So now this is fine. Okay. It may not be very obvious, but it's very helpful. Okay. And at the end, we're going to switch this proximity. Instead of a spherical proximity, we're going to make that into an actual geometry to trigger this setup. This is a part which I think is a little bit risky, because it depends on how much Falloff you actually add to the object. I hope increase the amount of subdivision will increase the parts being covered. But anyway, so let's add an object. I'm going to add a new node tree because I want to model something. You can use any geometry, for example, a blade. I have prepared a blade, but I want to model something. So let's take a circular screw. So let's start with a, let's say, field mesh circle. The good part of this field mesh circle is that it's a field with rings segment. Okay, this is actually a cylinder object, which is very simple and easy. You can also use a curved circle, but I want these vertices being counted as a way of evaluation to the final geometry. That's why I'm doing this. So let's take this, let's extrude that out. So we take a radial fall. You can see this radial fall looks like this, 360 degree. And then I'm going to modular that. As I mentioned earlier, that this Falloff is mapped from 0 to 1, and I module that to a low number, so we finally get this into 0.1. Okay, you see it's not a fully black and a fully white. This is simply because we do not have enough subdivision. Okay, I think this is fine. It may not be perfect, but anyway. And then we set a position to scale that up. I have the position and I scale it. Will it actually work? Because there are zeros, so we remap it. So we take a 1 and we take, oh, it becomes a fan object now. Actually, this was not my expectation. But I think this works. It's just that I need more subdivision. So let's take a value position. And I just keep dividing by 10s. Okay, this is too much. Maybe 5. Okay, maybe 3. So more blades. Maybe 2, so that it can divide. So something like that. I don't think people will actually see these much details. So I will just do this. So finally it becomes like this. I noticed that because it gives such kind of nice gradient, so we can combine X, Y, Z to make the shape a little bit popped up. So it looks like this now. This is a little bit like the lens apertures that we looked previously. Maybe 1. It's not very obvious. But anyway. Oh, let's remap yet. Yeah, so now it looks nicer. We do not need this anymore. Okay, so I think this is fine. We get this kind of a fan structure, and I just need to move that. We can. There are many ways we can rotate vector. And we combine Euler rotation. And then we can take a time info. We go to negative, so it runs the other direction. Maybe I take that to 15. Okay, so something like that. And then just rotate it. So we have this structure. I think we can take a solidify before. Okay. Yes. So now we have this structure. But I also noticed that I don't think this is an actual problem of not being 100% flat. I think I will just tolerate for now. Or we can only affect the top part. This is a very interesting question. Let's say we affect the we're going to multiply with the bottom value with only the top and the side. So this is definitely flat. The shading looks kind of weird, but it's flat for sure. I think this is fine. Let me think how to deal with that. I see we have this shading weirdness. Multiply. I think this is fine, but I'm thinking about other possibilities. Maybe we scale at normal. So we take a normal and we take a scale. So now it will go up and down. Okay, this is nice. And then we're going to make the blade sharp on the edges. So I want this kind of center is thick, and towards the outside it will become thin. So it's kind of a position. Multiply with 110. Then it becomes flat again. And I need to construct a fold for this 110. But the question is how to construct this fold. We can use a proximity fold. And then let's take the scale offset 1. The reason to do that is because the scale for our field mesh circle is 1. So you can see this Falloff looks like this. Now we can take the relative range of this Falloff to maybe 85%. This relative range is like the color ramp. That you are pushing these white ranges to maybe 0.15 so that the rest is white, just like what you see here. I think this looks kind of fine. Yeah, it looks kind of nice. So now we do this blade. We have this. Okay. Yes, it looks very nice. So now if I look at our cube, and I just need to use this blade or saw into the object, and I plug this into custom mesh. We use this custom mesh inside our proximity. So now if I touch that, use the relative position, it does not happen anything because we need this scale to determine how much it will emit these particles. Actually, instead of proximity Falloff, we can use a mesh Falloff so that we take the volume of this geometry into account. But actually, they don't make a huge difference in this case. I think this will just be fine. So finally, we have this animation. This is actually very simple. Yay. Let's make the blade a little bit tinier. At the end, let's add some deformation. This is just a sudden thinking. This is a noding anyway, so I didn't do this before. Everything was more kind of experiment. Let's take a volume cube. I don't know if this will work, but anyway, this will be extremely slow. It's actually will be pathetic. I hope it can work in this case, since this is just a cube. What I'm going to do, I'm still going to use this cube as a scapegoat for the stuff for the emission, but I'm going to output a volume cube as the final output. So let's mesh to volume, volume to mesh. Okay. Maybe decrease the scale a little bit. I'm actually not sure. Okay, this is half size. We take a negative and we'll take a 0.5. Then we have a half size cube. From minimum and maximum, there's 0.5, 0.5. Okay, and then I'm going to do some deformation. So I'm going to take some mesh Falloff. I think this is going to be the future workflow once we implement volume. The developers are already doing that, but I'm not sure how much progress will be done in 4.2. Okay. So we started with the density, which is 1, which constructed this cube. And then we're going to subtract that. We're subtracting this density with a simulation, and which is determined by this proximity Falloff. I hope it will actually work. So if we get close, we can actually see that because this part is being subtracted, it becomes like this. Okay, so this is actually working, but I'm not sure if this is being simulated properly. Actually, I think people won't really care because this is working in a volume. So if you goes too deep enough, this geometry will be deleted anyway. Oh, it works. It requires a simulation. Because if now I move that away, then it will recover its shape. It will not remember its state now. This is a tricky part. I need to think about it. I think this is a current limitation with our volume implementation within geometry nodes, because it's not like regularly we have these kind of geometries which can inputs and outputs through the line and store attributes along the way. The volume cube is not the same. And the volume cube is also the only node which is available for this kind of field evaluation. I know the situation will change, and I already see lots of new nodes being added for 4.2 for much better volume implementation. But right now, this is a limitation. I think there's a way to work around this issue. I don't think it's a very good idea, but I think I have no choice. We cannot store this volume cube inside the geometry nodes, or I mean inside the simulation zone, but we can store this saw object. So we take a joint geometry, and if my thinking is right, then it will look like this. Okay. And if you use all this kind of geometry, then this volume cube will definitely remember the status. Let's use this proximity 4 as the subtract. And actually you see the effect is right away. I'm going to use this volume cube to replace the proximity function, so that the evaluation to emit particles will also be changed along the way. And then we can actually cut this cube even into half. Oh, this is a fantastic idea. This actually looks kind of cool. Here I'm going to do another changes. I'm going to set position. I'm going to take a noise reading, and I have the color. The noise is applying to the entire things. We are going to only limit to the part which can be affected with this proximity, and let's increase the noise frequencies. 5 I think is enough. Let's reduce the scale. Then we have these irregular edges. Maybe make that a little bit larger. Maybe increase the frequency as well. Actually, this is very useful because we can also store this proximity so that we can use that as a color later in shader. Let's set shader smooth, and then we can set material. Just to make that as a cube. And in shader, we have this attribute. We have this 4. Goes to material preview. Then you can see that. You can make that into emission or other things. I guess it's possible to also record a time for this Falloff to fade out. Or maybe it's not possible. I think it's possible because starting from here, we already have this geometry which can run a simulation. But I don't think I'm going to do this in this noding. I think this noding has already been long, especially my throat feels a little bit tired. At the end, I just want to say, this noding was originally intended to make a simple project. Actually, this volume cutting cube thing is a complete accident. I wasn't thinking thoroughly when I started this. And you realize I actually prepared a collection of blades because I was actually inspired by blade fight. So I want to emit these particles. But from the middle points, everything has been changed. Yeah, this is noding. Sometimes you get a surprised thinking and the results. Other times you failed miserably. But this time, I think I get something interesting. I've never thought about this. So I think this is it. I hope you enjoy this video. I don't actually think I teach you. I don't actually think I taught you anything really in this noding, but this is a noding instead of being an actual tutorial. But anyway, I hope you enjoyed this video. I'll probably see you next time. Bye bye.